Yo. Alright, let's go. I'm excited. Getting more excited day by day because I gotta learn this. This shit. Bop. This guy. Some EOS shit that comes in with all these voice things. And the idea... I guess I'll talk a little. This is kind of my game. No, it's not my game channel, but just an idea real quick. Where we have person A, person B. Person A talks into microphone. We record that. And what we do is we play it like this. And hopefully in this direction. But we play it. And if person B is in the area where you can hear it, person B's here, he can hear it. If he's out here, he can't hear it. You could picture it being like, he's a little too far away to hear, just like in real life. There's a point of time where you're far enough from someone where you can't hear it. It's here. But the second you're close enough, there's a little whisper, and you add attenuation. We'll just do a little A here, attenuation, so that the closer you get, the louder the volume. Louder, right? So, the point here is that we need to set up the voice, and then record the voice, and then play the voice, and then attenuate the voice, and then somehow figure out add multiplayer at some point, so that we have person A record the voice, play it out loud, and person B can hear it. And say we're outputting, and then person B can record, and person B can hear it, just like a sound cue in any Unreal thing, and then person B can also talk at the same time, and if person A is close enough, he can also hear it. Cool. All right, let's go. We're not doing that because this is not my game channel. Copy constructor. Okay. All right. A copy constructor, because apparently there are different types of constructors that initialize things in different ways, apparently. Oh wait, hold. Okay, here we go. Default constructor, because both of these are default arguments. Or, well, both parameters have default arguments. Yep, so we have some private stuff. We got a public constructor. It's using a member list initializer to initialize these guys. We have a print function, so we can call fraction.print, and it'll print fraction, bop bop, 3453, whatever. Boom boom. So, hold. Oh, what is that? Wait. What the fuck is that? That's a thing? So we can do... What in the hell is happening? What is going on? So we call a constructor here. We're cool. And we call this constructor, but fraction f cop. This looks like it's its own. So like this constructor we don't call explicitly. But there's another constructor that we can call by adding copy to the initializer? Really? And the point is that, is this somehow like a better way of copying a class object instead of just creating another one and initializing it? I think I can do that, right? Can't I? Can I just initialize one with another? Or must I create a separate one? Well, how do we even name it? Oh, the point here is, oh, it doesn't need to be called fcopy. The point is that you call it by passing in the object. I was wondering what was going to happen there. Okay, cool. All right, now I'm coding. I want some music. Please. Cool. No, that was a good one. Wait, but this one could be good too. Oh shit, what a mistake that would have been. This is oh, it's Hanatan, dude. Tengaku is great. Oh, this is about to go crazy. Cool. So we can print the point. But then I can make another point duty called B, and we call it with A. And this is the copy constructor called. Can't see it. I think. Thanks for pointing out the extra space, yo. What is that? Oh, it's differences from a previous commit. Let's commit here. I'm hoping this is 232322. 232322. Fuck yes. Alright. So I was wondering what was going on here. I'm like, there's no way you can put copy at the end of an identifier, not seeing that we were passing. For some reason I was putting these together like, hey, if I pass this identifier to another instantiation, well, to another definition of a class object, for some reason I have to put in copy. I'm just stupid right now. Duh, this is another object that we're just calling a copy, a copy, a copy, a copy, and it's fine. Alright, no gooning. Alright, let's go. Let me check something. Okay, that's kind of sick. No, not this one. This is all wrinkly and bad. Dude! What? What'd you say? It's not long enough. This is like some sort of Steins Gate shit. Dude, that's not what I want. I want the full body. I want the extra large. Nah, it's some freaking gay British dude. I don't want that. Oh, this is closer. But it's fuzzy. Oh, getting there. Nah, some weird gay emo shit. Man, nobody has it, man. Nobody has it like this guy. This guy's got it on. Got it locked in. Alright. Alright. I hate how long this song takes to finish up. I don't have looper anymore? I do. What am I doing? Oh, it's right there. I'm fucking brain dead. Where's the annoying part? I think... this internet is so bad. Bro, hello? Hello? Bro, there's no fucking way. Is YouTube just piss? What is happening right now? $24. There it is. This is a different constructor because we don't have an explicit constructor here that takes in another fraction and then initializes m numerator to be that fraction m numerator and that fraction m denominator. Do we see something that looks like that? Fuck yes. Let's go. Oh. Here we go. Nice! I was hoping there was something like that. The question is, why does this work? And it works because there's some other constructor that's hidden, just like a default constructor that we don't even specify. We don't say, oh, hey, fraction bop bop is default. We just say, leave it. There's no explicit constructor. It has one invisible that the constructor or the compiler creates. Initialize an object with an existing object at the same time. And I can call it for temporary, right? Nice. Oh, I can print a temp like that. Nice. And it's an R value, so we can print it. Because we're taking a const reference. And a const L value reference combined to an R value. And it is implicit. Makes sense. For example, we're gonna pretend this is 7 days to die. Back when you could take a gun, disassemble it for parts, and then create molds of the parts. Stupid. Terrible change. This is amazing. What a great part this was. Just a great idea. Yeah, it's just trash. Let's do class gun part. Okay? Okay, it has two pieces. There's a constructor. Gun part is, I keep forgetting, but I keep remembering. Eventually it'll get there. ears itching. And that motherfucker blank. Well, it's not default, but it's... I don't want to make it default because then... Well, I guess if we omit both, then it's okay, huh? I just can't only omit the first. What if I do that? Nah, I figured not. Yeah, it still has to be like that. Well, I'd honestly just rather leave it like this so that we have default arguments anyway, right? Okay. We'll do, set. I like getters first for some reason. I'm not great with that syntax where we have two braces and then I put a semicolon in the middle. I'm used to putting it at the end of a line. Gotta break that habit. Not const because we're modifying a data member. Maybe in this time we're just gonna create a member function just because. Oh, I may as well just do. Cool. It's like some sort of hidden character there. I can't tell what it is. For 3. Alright, and then we could do now. Whoa, really? Or must I? Are you sure, bro? I'm not sure what this constructor needs to look like then. It can't really? I thought we were taking it and saying the member selection operator. Are you sure? Are you sure too? Why is it cool now? Are you still sure? It really doesn't like this guy. Oh, it needs a reference to another. You can't have one with an interesting. Noted. I should have. Well, I mean, I wouldn't have guessed that. A reference to another gun part. Wonder why. Well, I guess you need another well, yeah, I'm not really sure why, honestly. Excuse me. Oh, wait, what? Cool. So we have 32 and then 390. Alright, that works. We just need a reference to another object. Okay. Make our own so you can show that it's executed when copies are made. Oh, meaning that we can actually see what's happening here. True, I haven't debugged in a while. Okay, so it's calling that constructor and it's insta-made and then the body's done. Or hold. Oh, I guess it went to the body first. Saw nothing and then went to the top, something like that. Or it went there, sure. And then it went and initialized piece 1, initialized piece 2. And then this just has the memory address. Oh, because it's a pointer to the gun. Alright, that's not an issue. I just haven't looked at creating a class and watched the values. And we have the garbage values here. Now we have this. Oh, it actually didn't even. Oh, fuck, I accidentally skipped over. Damn. Let's do a breakpoint here. No, no, no. There we go. No, fuck. There it is. Oh, wait, hold. Fuck, I did it again. And then here we go to the copy constructor, where it goes to the body for a second, and then it goes and actually visits the member list the member initializer list. So you get piece 1 for the other object, finish that initialization, get the other piece, finish that initialization, finish no body, boom, 90. Set the piece to be 90. Boom. Print. Or, well, actually, I guess that was printing. But no, there it is. Set 90. Now print. Boom. Cool. Why didn't that fucking close? Okay. Is there a way I can just make it close? That's annoying. Well, options, debugging. It's fine. It's not a big deal. I gotta wimp up, man up. Alright. Looks just like you'd expect it. Makes sense. Yeah, it takes a const reference to another. but it's another that's existing. Well, it could also be an R value though, so even an R value works. And the reason it needs to be a reference is because if we just do a regular, well, we could do copy by value, but I guess one we wouldn't want to, because that could be expensive. Because we make a copy as a temporary, which we then initialize, so we're doing it twice. And in another hand, if we passed an R value, well, R values and L values alike would be copied. So we need it to be const so that we can pass an L value, or an R value. Okay. But you could just allow it. I'm not sure why we don't allow just doing a regular fraction. Per class and upper object, yes. Meaning that even if the shit is private, it can still be accessible. Yup. Oh, duh. Well, I almost still prefer that, but... And I guess the point there is so we don't have to make a copy of this into some temporary variable, which is then initialized. It just goes boom to boom. But I think it's copying either way. It's not, well, hold. It is accessing a reference in this case. So we don't want to do a copy to get a temporary if we're already doing a reference. So I guess maybe direct makes more sense there. If we didn't want access functions, okay. So if you didn't want them, all right. Please. Copy elision. Elision almost seems like omission. And elision feels like fission, which is like conflict cutting or something. No side effects beyond copying, okay. Prefer the implicit. Oh, wait, hold on. Unlike the implicit default, which does fucking nothing and doesn't even initialize the guy, we want an actual constructor so we can do member-wise and we don't have to freaking copy bullshit. The member-wise initialization with the implicit copy is cool. So copy is good. So we make a better constructor for initialization, but the copy is good. Dynamic memory allocation. Okay. Oh. Well, yeah, a lot of people know that. Okay. Must have a reference. Here it is. Makes sense. It needs to be a reference. Noted. Wait. When an object is passed by value, oh, meaning that I'm passing an object into another object to copy it. The value, the argument is copied into. Oh, okay. So we're talking about. The argument is copied into the parent. Well, hold. So it's copy. I mean, it makes sense. I'm not sure why we're saying this. Why aren't we just saying that, hey, we're looking at a place in memory with an object, specifically an alias, but we're looking somewhere wherever the object is, and we're copying the values one time. There's no temporary. There's no pass by value. We're passing, sure, a reference technically, a value, a pointer, a memory address to look at that object and take the values. Boom, one copy. That's it. One assignment. And we're taking it straight from here to here. Or, no. Yeah, I think that's it. The copy's made implicitly. What are we talking about here? F is copied into the function parameter. Really? By, hold. Oh, into the function parameter using copy. Wait, into the function parameter. What the fuck are you saying? Copied into the function parameter using copy constructor? I don't know what the fuck you're talking about. That wording is retarded. Why is it that this is by value and not by reference? Oh. Hold on. Print fraction. F is copied into the function parameter using the copy constructor, meaning that there's a temporary that is created here, and it is initialized by looking in memory here. So there is assignment here, and it's because this isn't using a reference. This is just a retarded fraction. This should be a reference. Let's warm up for push-ups. Excuse me. All right, should be good. All right. Return my value? Oh, meaning function returns a temporary object. Or we're passing maybe a reference, and then we're returning a copy of it. We're returning the object at this place in memory, and we are copying it, so we are passing that reference into a copy constructor to create another temporary object that's an R value, which is then returned by that function. So by calling a function that returns a class by value, that function is copying it with the copy constructor. Class something named A. Passed a function called create object. Passed by reference, return B, or return an object, and it returns that object. Not a reference to that object, and not returning a reference, returning a class, that object. By reference, copied, inefficient, maybe. Yes. And when the return type and the return value are the same class type, por ejemplo, we have an example here. There we go. Remembered first time. I just need a regular constructor here. I'm not going to do anything crazy. I think that's it. So we could call so what's happening is this finds a place in memory, creates this object, instantiates this object by calling the, well, it's not a default constructor here, but calls the primary constructor, creates this object, it exists in memory. But then we are returning this object, not as a reference, not looking at where that place in memory is and taking those values and moving them to wherever this is called. No. It's instead creating another object, a temporary right here. And it is the return value that is found here. Boom. Can we see the copy constructor being called? I don't know. Let's find out. We call getEjemple. We create this object and we call this guy because we're passing it the numbers member wise. We're calling the regular constructor, which goes initializes. Cool. But then we're returning an A. Fuck, it doesn't show. Damn it. I was hoping it would show. It called this, allegedly, in a second, it called this to return a temporary copy. How did it get a copy? What it was really doing is it was creating another little ejemplo. I mean, it's really returning, excuse me, we could return A, or we could return ejemplo A. Same shit. It's creating another object and copying it. And actually, that might have even been the worst way of doing it, because then wasn't it copied from that too? No, I don't think so. Maybe it was, though. No, I don't know. That might have been 3 assignments. Create object, give it values. Create a temporary object from that one's value. I don't know about that, though. Oh, and it's implicit, so maybe we just don't even see it. All right, we have main fraction f2 to create, and we're going to generate a fraction, and then we're going to print a fraction. So we call generate fraction. We pass in 1 and 2. What it does is creates a fraction. It's identical to what I just made, except mine was called get a ejemplo. And we create a fraction called f, pass it n and d or whatever the hell. We passed it 1 and 2 in this case. So it creates this fraction that exists. And numerator, denominator, gotcha. And then it creates another temporary, well, it returns that as a temporary here. So we created once, or we assigned value once, and then created another to actually return the values here. So we created an assigned value, created an assigned value. Instead of just creating and assigning value, assigning value. Assign value once here, which is used to assign value here, which is used to assign value here. Oh, fuck all that. It's 3 times. And then we're calling print fraction. So we have 0 and 1 because invariant. Regular constructor. Default is 0 and 1, so 0. In this case, we're returning a temporary. So it would call this guy, pass in a reference to f, create a temporary, and return that one. There's the test. That's how we can test. The debugger won't show it, but oh! Get a ejemplo. Nothing. No copy. No crazy constructor stuff called yet. Initialize with 3. Initialize with 4. Done. Create temporary. Boom. Wait. Hold. Hold. Initialize. Oh, so it is initialize first. Initialize first. Boom. Wait, did I just skip this earlier? I must have skipped over it. And it returns them, bam, right there. Create that temporary object. Nice, I was right. And the reason it does it all these fucking times here, this is trash, is because we generate a fraction, and it one creates this guy regularly, returns a copy here, first one, but then we do print fraction f2. And then we call print fraction, and so what happens is, oh shit, because wait, is this evaluating? Hold on. No, we're just passing f2, so doesn't this just create another, so it calls it the second time? I'm not sure why it does it a third time there. Unless you're saying that it... Oh. On the author's machine, let's see what happens for mine, because my logic tells me that this would only be 2. 1. Man, I'm doing some heavy ass elision. And it's because we create 1, we generate fraction. Okay, not here, but here we create a temporary and return here. But then we call F2 here, or we call print fraction and pass it F2. And we're calling print fraction. So I would think that it would create a temporary here, so it would do it a second time. But then we just print that, and then it returns. So I don't know why. I'm surprised it's only doing it once in this case, really. Create normal. Good. Return via copy constructor. Hold, wait. Wait, it didn't do it? I don't even know why it didn't do it. It didn't even do it there. In that case, did it replace it and just return by reference somehow? We're not returning by reference. But then when we call the print, hold, then it does the copy constructor because we passed it to the print function to actually initialize a whole parameter compared to just returning here. Okay, interesting. So it can happen a different amount of times. Just depends on the compiler, I guess. When it returns a fraction, when generate fraction returns a function back to main, it's returning a temporary fraction. Yes. Because the temporary is used. Wait, hold on. There's one here. Wait, really? Wow. So 1 generate fraction yields 1. I missed that. I forgot that the process by which it's initialized is the copy constructor. So we actually create a fraction, no copy constructor, just regular constructor. Return a temporary via value like a dumbass. In that case, it is what it is. It's got to be value. We return it. Well, yes. Because otherwise this guy is, well, yes. Well, we could avoid returning a temporary. We could return an R value, but no, because then it's dangling. It would have to be static. Fuck. All right, well, returns once by value. The initialization process, so this generates 1, because it calls to create 1. Return calls to create another. And, well, to initialize another. Then initializes F2, which calls the copy constructor again. And then we call print fraction, which initializes another F with the copy constructor a third time. Holy shit. Using default to generate a default copy constructor. Oh. And if we already have a well, excuse me. Oh. And then I could do the same thing with a reference to delete it to disallow copies. Excuse me. Oh, so it still works. No copies. You cannot call the the constructor, the copy constructor. Makes sense. Oh, true. So only inside, and the reason that wouldn't work is because main would be calling that function or that function. But you could call something in this that would make it copy. Yeah, exactly. Don't know why I would want that. Rule of three. Rule of three is if it requires any of these, it probably requires all three. So if it requires a user-defined, if it requires a user-defined copy constructor, destructor, or copy assignment operator, because we don't know how to, oh, can I overload it? Isn't that similar? Oh. Oh. Copy assignment operators. Oh, but it doesn't necessarily have to have a copy assignment operator. Oh. I was gonna say, because I would think that we would just return the left operand, or we'll. Hold. How does that work? If I say an object, does it return this? Because I'm thinking, and no, I guess it's fine, right? But it's already an object that exists. I'm trying to think, if I create an A is a class. If I create A X equals copy assignment operator, B, which B is also an A class, or Y is also a class A, then I could see a world where we could return, where that calls a function. I guess we assume that X has already been created. We return the left operand, so we return an A, a class A, and then, or we return a reference to A for chaining, I guess. And then the first parameter, and then we do operator equals, and then we do A X, A Y, or A whatever, A B, and then call the copy constructor. Something like that. No, the copy assignment up. Oh yeah. Copy constructor. The rule of 5, which adds the move constructor and move assignment operator. Interesting. Malfunctioning code, meaning that we write it and we're missing some shit. Okay. Next chapter, destructors. Why aren't we allowed? Oh, yeah, that was my question initially. Why aren't we allowed to pass by value? Oh, is that recursion? Hold on. If I pass it by value, doesn't that mean that we have to create the another object? Object. No value has value. I want to copy this here. If I pass you by value, I have to evaluate you as a temporary to assign you here. How do I create a temporary? Copy constructor. Recursive? Maybe? Like, the act of passing by value requires the copy constructor. In the copy constructor's definition, well, the act of passing by value requires the copy constructor. In passing by value would be how we pass something to the copy constructor. It seems like that's why. It must be a const reference. Why aren't we allowed to pass? Oh, well, and it could also just be, well, there's the question. It's a const, I guess that's the hard part of this question. It's a const reference, so why can't we pass by value? Why can't I just do a const reference to the R value? I think it's because passing by value requires the creation of another object, whereas in the copy constructor, we cannot do we can't create an object in the creation of another object, right? Well, yeah, we have to do a reference so that we're not creating another object, and it's const because we shouldn't be modifying it. That has to be it. It's because it would require the creation. Right? Boom! Give me that! When we pass a class type argument by value, the copy constructor is invoked to create another copy of it. A, B, copy into him. How do we do that? Evaluate, create a temporary. Boom. Why? I don't know. Oh, it's because that's just how it is. There's different types of copying, or well, different types of initialization. We can put the value straight there if we look here. But for some reason, the default way, at least with one operator that's easy, when we're making the process of copying something, so passing by value is like copying it, where we're evaluating it as a temporary and then putting it there, not evaluating it as where it is, because assigning is by default passing by value, I think, something like that. Yes. When we pass a class type argument by value, the copy constructor, well, a class type, okay, gotcha, meaning an argument that is a class type, not an argument of a class type, because that's a data member, not an argument. The copy constructor is invoked to copy the argument into the parameter. Yes. Boom. If the copy constructor used pass by value, meaning in the copy constructor it was using a value of something else, something would have had to create the object that the copy constructor is using, the temporary, the parameter. How are we initializing the parameter with it if the copy constructor is the thing that is initializing the parameters? It would need to call itself to copy the initializer argument into the parameter. Exactly. How do we get into the parameter? How do we go from here to here in main into our copy constructor as a parameter, as a function parameter, basically? It is a function parameter. That creates an object. But that call would also pass by value. Exactly. Motherfucker, I told you. Recursion infinite, yo. And now let's see in what cases we're allowed to omit the constructor and force returning by value? Maybe? Actually, there's a good question. When we're returning like that, when we're passing a class and we're returning it, what am I doing? I may as well just make it. Oh, you fucker. Oh my god, I can't redo all. Oh, great. I don't have time for this. Oh, hold. Alright, here we go. Regular constructor called once. Call, get a template. Here, regular constructor, because we're initializing it with list member, well, with list member initialization. Or member initialize a list. Excuse me, via the regular constructor. Not default, because it doesn't have default arguments. And then we're copying this guy in here. But then excuse me. Oh, it does do the copy again there. What if it returns in a template though? Well, just as an example. It does it again. Okay, it keeps doing it in every time. I don't know when copy elision's happening. Because it didn't happen in this other case, but alright, we'll find out. Next time on. Okay. Let me read! Hold on. Push up time real quick. Yeah, 45-minute self-test every day is the best. This is so much better. 2 hours and 15 minutes of learning each time? Oh yeah, push up time. 5 each arm. Straight. No. 3 in a row each arm. 2 in a row each arm. 2. 2. 4 piece, maybe? Oh, wait, hold on. I'm too far away. Alright, there we go. I'll start right arm. Hold on. Everything is near me. Why? I can do that. 3. Oh, fuck. Again. 1. I need to stay straighter. Oh, I can do better. Okay. Oh, fuck. 6 apiece, baby. Form's getting better. All right. Copy elision. Is elision similar to omission? Is it like just killing dead code, or a process by which the compiler optimizes it out? It's a long chapter, unless there's a lot of comments. It's a lot of comments. I'm honestly not averse to a tattoo since I still have this shit on my arm. Oh, it's finally coming off. Wow. I'd probably be pretty particular about it staying in good condition though, so I wouldn't do that. It's too expensive. Nah, good cross though. What about... That is sick. It's a different type of cross though. Bro. That's kind of cool. A girl? Oh hell no. Woohoo! Uninitialized, default initialization, copy initialization, direct initialization, copy list initialization, value. So default, value, copy, direct, list, copy list. Well, yeah, copy list direct. Yeah, perfect. Yeah, that was it. It's just you could also say it's direct list. I'm not sure the difference, but I know that it's called list at least. And this uses it interchangeably. I say list because it's faster. They're doing it all these different ways, okay. So we have the default constructor with nothing, which is effectively calling it with no arguments. Direct. But these are all... The syntax is different, but isn't it the point here that these processes, all these different types of initialization are valid, but they all call different things. So we have default, no arguments, value, no arguments, using no values in this case, but copy, direct, list, copy list, but they all function as regular ass copy, seems like. Or they copy the value here and then boom. And then when it all depends on what we're giving it. If we give it value, little values to initialize the members, boom. But if we give it a whole object to copy, we do boom. We call the copy constructor versus the normal. Okay, nice. It is called the normal. Too crazy. Woohoo! 5-second delay. Gotcha, because there are different overloads that resolve to the same shit. Like I could have, well, yeah, I mean, I can imagine different overloads. We got all these different types with different types of parameters. An L value class and an R value, L value class, R value, L class, R value, all these different versions. L value class, boom, 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 boom. Implicitly converts to R value, copy constructor. Already an R value, normal constructor. Nothing, default constructor. Thus we have a user defined default constructor. Well, duh, list disallows narrowing, we know that. Copy initialization only considers non-explicit. I don't know what explicit is yet. Okay, we'll learn that soon. List prioritizes matching list over others. Don't know how that works. Oh, meaning if there's something that uses something like that. There's some sort of list favoring. Like if we could initialize it with a vector that has multiple things versus just one variable, maybe it prioritizes the vector because that uses list somehow by default. Yeah. And constructor member initialize the list. Yeah. In the member initialize the list, we can't use copy assignment or copy initialization here. Unnecessary copies. So we create something S. Will make sense. So we're first creating an S. We have MX. Then we're calling the first constructor, the normal constructor, with 5, which is using a member initializer list to initialize MX. We output normal constructor, and we've created an object. But it's a temporary object. And we're then returning that. Well, we're then calling that as an argument in a copy constructor to create S. So we've created a second one. So we've done a normal constructor and the copy constructor. And then we're printing yeah. Makes sense. We've done 2 here. That's what happens when you create this. Instead of just giving it 5, you create another one and then return it as a temporary for some reason. Need something crazy, something hard. Another voice. This guitar is ass. It all comes down to the voice now. Yeah, this is terrible. Absolute trash. Disgusting. This will be good. No, I don't care. Drama. Oh, I know this. Really? The end result is actually only the regular. There's no copy constructor. It just says this and then sees that you're initializing another guy with it. So it just keeps this guy in memory and that's it. Or because it evaluates this and then removes the useless construction and the copy and just does the normal constructor. If we're creating a temporary to initialize the permanent, why the fuck aren't we just initializing the permanent in the same way? Constructor has been elided. Oh shit, meaning that it could totally fuck up the behavior, which means that if you ran this, it would only give you the normal constructor, and it would change behavior, so it means it's exempt from that. Exactly. Even if it has side effects. Yep. Makes sense. Make your copy constructors just copy. That way, if they get elided, boom, they're gone. And no behavior changes. Let me check something real fast. Yeah, I thought that was the case. Started to taste a little bit of funky in my mouth for some reason. I knew it. I had to scrape my tongue off. I have this metal scraper thing. Just because the shit builds up on your tongue over time. People with white tongues, disgusting. Turns out mine was disgusting. GG, I'm disgusting. Makes sense. Yeah, make good copy constructors and then you won't have behavior change. Yeah, that makes sense. Makes sense, yeah. Copy elision and pass by value and return by value, huh? It's normally called... Are we doing some stupid ways? Here we go. Yes. I can already tell because we're initializing with some bullshit. So, we're calling RVO. RVO returns the default something, which is bullshit. Okay, well, you may as well have just done that. So instead of calling the default and then the copy, you may as well just call the default and call it a day. And then another one with S2 initialized with NVRO. We're calling something with the default. We're then copying it, and then we're copying it. Are we doing two normals, I'm hoping? Or all, oh shit. Well, yeah, because we're doing... Wants to create, wants to return, wants to create, wants to return. Oh shit, and one's here, so maybe... Oh yeah, once when it returns something to main, because we're creating a something. Yes. And another when we're using it to initialize this guy. Yes. Another one we call this guy. We'll hold. I mean, really, it should be 5. 1, 2. Default, copy. Default, copy, copy. It should be 5. Excuse me. Cool. Mandatory copy elision. Oh. Hmm. Meaning in cases where it isn't guaranteed that we need a constructor to create it? I mean, that would make sense. In mandatory, it doesn't need to be available because it's going to be removed anyway. Okay. Because it's not going to be called. Interesting. Compiler smart. Good job, Bjarni. Straw strip. Oh. So is it the case that we're creating an object somewhere here, and instead of creating an object and then having to copy it to create another object to initialize here, how about we just move this object to wherever this place is going to be in memory? Move semantics, meaning place here, temporary is created here, need it to be here. Why not just move the information here? Is that more expensive than just assigning the value there? I don't know. I don't know. Is it more expensive to move houses or to just order new shit? I don't know. No clue. Oh, that's a long... No, it's not. Is this the longest of the chapters? Significantly. Yeah, much longer than any other chapter ever. Cool. Doesn't matter, but I'm just a wimp. Explicit. Oh, so... why do we need explicit? Wouldn't we just say, like, if I'm returning a temporary, I can just return a factor, or return a fraction, something, something? Instead of needing to say explicit? I don't know. Oh, maybe... Yeah, I don't know. Sorry. I need a haircut again. Damn. I'll get one tomorrow. Yeah. No, I can't. I got fucking sports shit. Boring. And I can't back out either. I could go at lunch. Nah. That could be good though. Maybe a less weight. Maybe a shorter weight. Yeah, sure. So we can pass a 5 to a double. A double is numerically converted to a... sorry, an int is numerically converted to a double. Boom, we're good. Yep. Oh, shit. This is gonna be good. Great. Great work. Oh, and it goes hard too. Not as hard as the original, but oh my god. Oh, we're done? Really? Fuck, I wasted time. Whatever. All right, more later. Okie doke. I'm gonna open up an Unreal project, I think, because I think recording will fatigue me. So I'm gonna just try and learn some shit in my off time, maybe, in my break time. Okay.